Have you ever reached out to touch the solid wood of a heavy oak table, feeling its firm, unyielding surface beneath your fingertips, and wondered if what you are experiencing is actually real? We move through our daily lives with an absolute certainty in the physical world around us. We trust the ground beneath our feet, the air we breathe, the warmth of the morning sun on our skin. But the deepest discoveries of modern physics suggest that this comforting solidity, this intuitive reality we all share, might be nothing more than a persistent, beautifully constructed illusion. Our brains are incredible prediction machines, taking the chaotic soup of sensory data and weaving it into a seamless tapestry that we call the universe. But when scientists look closely, when they peel back the layers of this tapestry using our most advanced instruments, the fabric of reality begins to fray. The solid objects dissolve into clouds of probability. The absolute march of time becomes a flexible relative dimension, and the very concept of physical matter begins to look more like pure information, dancing in a vast silent void. This disconnect between what we feel and what actually is has troubled philosophers for millennia. But now, it is terrifying some of the most brilliant scientific minds of our generation. The mathematics are pointing toward a conclusion that challenges the very foundation of our existence. If you enjoy diving into these profound mysteries of the cosmos with me, allow me to introduce myself. I am Dimitri Isledovatel, your gentle guide through the strange and wonderful universe we inhabit. I recently noticed that 76% of the people who watch our quiet journeys have not yet subscribed to the channel. If you find peace and wonder in these explorations, please take a moment to subscribe. It helps us tremendously and ensures we can continue unraveling the infinite mysteries of space and time together. Now, let us return to the nature of our reality and take a deep breath as we step into the unknown. Let us begin with the most basic assumption we make about our world: the idea that objects are solid. When you press your hands together, you feel a distinct stopping point, a boundary where one hand ends and the other begins. When ancient philosophers first proposed the atom, they imagined tiny, indestructible spheres packing tightly together to form the world we see. But in the early 20th century, scientists began to look deeper, and what they found was a vast, echoing emptiness. If you could magnify a single atom of hydrogen so that its central nucleus was the size of a marble sitting in the middle of a large sports stadium, the single electron orbiting that nucleus would be a tiny speck of dust flying around the highest seats in the furthest stands. Everything in between that marble and that speck of dust is absolutely nothing. It is a quiet, pristine vacuum. This means that the chair you are sitting on, the screen you are looking at, and the very body you inhabit are made almost entirely of empty space. To be precise, normal matter is roughly 99.9999999% empty space. If we were to remove all the empty space from the atoms of every human being on Earth, all 8 billion of us could be compressed into a volume smaller than a single sugar cube. You are a ghost, moving through a ghostly world, sustained by the illusion of substance. So why does the world feel solid? Why do we not fall through the floorboards and sink into the center of the earth? The answer lies in the invisible forces that govern the cosmos. The electrons that orbit the outer edges of atoms carry a negative electrical charge. When the atoms in your hand get close to the atoms of a wooden table, those negative charges repel each other with an astonishing ferocity. What you feel when you touch a solid object is not matter touching matter. It is the invisible force field of electromagnetism pushing back against you. You have never actually touched anything in your entire life. You are simply hovering a fraction of a millimeter above the surface of the world, suspended by an invisible cushion of energy. This revelation alone is enough to induce a sense of cosmic vertigo. The reality we perceive is a useful hallucination generated by our nervous system to help us navigate a world of invisible fields and vast microscopic voids. But this is only the first layer of the mystery. As physicists pushed further into the quantum realm, the bizarre nature of reality became even more pronounced. They discovered that the fundamental building blocks of the universe do not behave like physical objects at all. They exist in a state of fuzzy probability, a fluid dance of possibilities that only solidifies into a definite reality when it is observed. Imagine throwing a pebble into a quiet pond, watching ripples spread in perfect circles. Now imagine throwing a grain of sand, expecting it to act like a tiny projectile, landing in one specific spot. In the quantum world, however, the rules are entirely different. When scientists fire single particles of light, called photons, or single electrons through a barrier with two tiny slits, something impossible happens. Instead of acting like tiny bullets and creating two distinct lines on the wall behind the barrier, they create a complex pattern of multiple stripes, an interference pattern that can only be created by waves crashing into each other. The single particle somehow acts like a wave, passing through both slits at the exact same time, interfering with itself, and only deciding where to land at the very last microsecond. It is as if the universe is keeping all its options open, existing in a state of endless potential until the exact moment an observation is made. But here is the part that keeps physicists awake at night. If scientists place a detector at the slits to simply watch which path the particle takes, the wave pattern disappears completely. The particle suddenly acts like a solid little bullet again, passing through only one slit and creating two simple lines on the back wall. The mere act of observation, the simple presence of conscious measurement, forces the universe to collapse its infinite possibilities into a single concrete reality. This is not a failure of our instruments. It is a fundamental property of the cosmos. The great physicist Albert Einstein once famously expressed his deep discomfort with this idea, asking a colleague if he truly believed the moon only existed when someone was looking at it. Einstein believed in an objective reality, a universe that ticked along like a giant clockwork machine, regardless of whether anyone was there to watch it. But decades of rigorous experiments have proven Einstein wrong on this particular point. The universe, at its most fundamental level, is not made of solid, independent things. It is made of relationships. It is a participatory universe, where the observer and the observed are locked in a quiet, eternal dance. Without the observer, the concept of a defined physical reality begins to lose its meaning. If the building blocks of our bodies and our world only take on definite properties when they interact with a measuring device or a conscious mind, what is the universe doing when we are not looking? Is the dark side of a distant planet in a far-off galaxy existing in a state of blurred probability, waiting for the gentle gaze of a telescope to bring it into sharp focus? We are accustomed to thinking of ourselves as tiny, insignificant observers, dropped into a vast, ancient and indifferent cosmos, we look up at the night sky and feel small, humbled by the billions of years and billions of light years that stretch out before us. But quantum mechanics suggests a radically different narrative. It suggests that consciousness, or at least the act of interaction, is deeply woven into the very fabric of reality. We are not mere passengers on a rock hurling through a cold, dead void. We are active participants in the ongoing creation of the cosmos. Our presence matters. The universe requires a witness to transform its whisper of potential into a symphony of reality. This is a beautiful and empowering thought, a gentle reminder that we are intimately connected to the deepest mysteries of nature. But as science marches forward, a new theory has emerged, one born from the study of black holes and the fundamental nature of information. It is a theory that takes the strangeness of the quantum world and pushes it to an almost terrifying extreme. It suggests that the three-dimensional universe we experience, the vast depths of space, the billions of galaxies, and the long march of time itself, might be a holographic projection originating from a distant, two-dimensional surface. It sounds like a story woven to thrill and entertain, but it is grounded in the rigorous mathematics of modern theoretical physics. As we continue this journey together, we will explore how the destruction of information inside ancient black holes led scientists to question whether everything we perceive is nothing more than an intricate mirage. The silence of the infinite universe holds secrets far stranger than we ever imagined, and our exploration of this quiet, majestic illusion has only just begun. We will learn to find comfort in this grand mystery, allowing the vastness of the cosmos to bring us a profound and lasting peace as we drift further into the unknown. Let us travel in our minds to a place where the familiar rules of our reality stretch until they simply break. Imagine a star, ancient and massive, perhaps 20 times heavier than our own sun, burning brilliantly in the quiet depths of space for millions of years. When this giant finally exhausts its nuclear fuel, the gentle outward push of its radiation ceases, and gravity, the most patient and relentless force in the universe, takes absolute control. The star collapses inward with an unimaginable ferocity, crushing its own core, until the matter is so densely packed that it punches a hole in the very fabric of space and time. This creates a black hole, a region of the cosmos so dense that nothing, not even light, the fastest messenger in the universe, can escape its gravitational embrace. Around this point of infinite density, which physicists call a singularity, there lies an invisible boundary, known as the event horizon. It is a point of no return, a silent threshold where space itself flows inward faster than light can swim outward. For decades, scientists viewed black holes as the ultimate cosmic vacuum cleaners, dark and silent monsters that devoured everything that wandered too close, offering absolutely nothing in return. They were considered the absolute end of the line for matter and energy, a place where the story of a particle simply stops. But science is an infinite journey of discovery, and the universe rarely settles for simple endings. The true nature of these dark spheres holds a mystery that is far more profound, and it is a mystery that forces us to question the very dimensions of our reality. A profound sense of wonder washes over us as we gaze into this darkness, realizing that the absence of light is not the absence of physics, but the beginning of a completely new set of rules. In the 1970s, the brilliant physicist Stephen Hawking turned his mind toward these cosmic shadows and made a discovery that sent a shock wave through the scientific community. Using the mathematics of quantum mechanics, he realized that black holes are not perfectly black. The boundary of the event horizon is a chaotic, bubbling sea of quantum fluctuations, where pairs of virtual particles are constantly popping into existence and annihilating one another. Hawking discovered that occasionally one of these particles falls into the abyss while its partner escapes into the vastness of space. Over incredibly long periods, over billions and trillions of years, this steady leak of radiation, now known as Hawking radiation, causes the black hole to slowly lose mass, to shrink, and eventually to evaporate completely into the silent void. But this brilliant realization created an enormous theoretical catastrophe, a paradox that threatened to break the most fundamental laws of physics. In the world of quantum mechanics, information is sacred. I do not mean information like the words in a book, but the precise quantum state of every particle, the exact arrangement of matter that makes a star, or an apple. Physics dictates that this fundamental information can never be destroyed. It can be scrambled, burned, or scattered across the cosmos. But theoretically, if you had a powerful enough computer, you could always reconstruct the original object from the scattered pieces. But if a black hole swallows an encyclopedia, or a star, or a human being, and then eventually evaporates into a cloud of random, featureless radiation, where does that unique quantum information go? Hawking initially suggested that the information was simply lost forever, erased from the cosmos, but this meant the foundational laws of quantum physics were completely wrong. The silence of the scientific community was deafening as they grappled with this terrifying possibility, forced to choose between the gravity of Einstein and the quantum rules of Bohr. The battle to save the laws of physics, known as the black hole information paradox, raged for decades. Physicists like Leonard Susskind and Jacob Bekenstein eventually proposed a radical, almost magical idea. They suggested that the information of whatever falls into a black hole is not swallowed into the three-dimensional depths of the abyss. Instead, the precise quantum blueprint of every particle is perfectly preserved, encoded as a two-dimensional pattern on the surface of the event horizon itself. Imagine dropping a beautifully intricate three-dimensional object, perhaps a delicately carved wooden box, into the dark waters of a lake. As it sinks beneath the surface, imagine that the ripples it creates perfectly encode every microscopic detail of that box upon the two-dimensional surface of the water, a frozen mathematical imprint left behind on the boundary. The object may be lost to the depths, but its complete informational identity is perfectly stored on the surface. When the black hole slowly evaporates, radiating its energy back into the quiet cosmos, it carries this encoded information back out with it, subtly imprinted on the escaping Hawking radiation. The sacred law of information preservation is saved. But the cost of this salvation was a fundamental shift in how we understand the nature of volume and space. It required a complete reimagining of the cosmic architecture, shifting our focus from the vast, empty volumes to the seemingly flat, restrictive boundaries. If all the three-dimensional information of a dying star can be completely and perfectly captured by a two-dimensional boundary, it means that the three-dimensional volume inside the black hole is, in a mathematical sense, redundant. It is an illusion generated by the information written on the surface. The physics of the three-dimensional interior is perfectly equivalent to the physics of the two-dimensional surface. To understand this, think of a security hologram, the kind you might find on a credit card or a piece of software. It is a completely flat, two-dimensional piece of plastic. But when light hits it at the correct angle, it projects a fully realized three-dimensional image that appears to have depth. You can look around its edges, you can see shadows and volume, but it is entirely a projection from a flat surface. The black hole operates on the exact same principle, but on a cosmic, fundamental scale. The intense gravity does not crush the information out of existence. It simply smears it onto a flat screen. This realization brought a profound peace to the physicists who had wrestled with the paradox, restoring harmony to the laws of nature. But then, theoretical physicists took a step back, looked at the mathematics, and asked a question that continues to echo through the halls of academia today. If the interior of a black hole is actually a holographic projection of its two-dimensional surface, what if the exact same thing is true for the entire universe? This leap of logic is breathtaking. It takes a localized phenomenon, an extreme edge case of astrophysics, and applies it to the very fabric of everything that exists, proposing that the ultimate truth of the cosmos is written on a distant wall, far beyond our reach. What if the vast three-dimensional cosmos we see when we look up at the night sky, the billions of galaxies, the endless oceans of dark matter, the gentle rotation of the planets, and our own physical bodies, are all essentially a holographic projection? What if the true, fundamental reality of our universe is a two-dimensional surface enclosing our cosmos, covered in microscopic quantum data, and we are merely the three-dimensional manifestation of that incredibly complex code? It is a staggering thought, one that forces a sudden, humbling shift in perspective. It challenges the very nature of the space we inhabit, suggesting that depth and volume might not be fundamental properties of nature, but emergent phenomena, like the sensation of heat emerging from the rapid movement of invisible molecules. As we prepare to delve deeper into the mathematical framework that supports this terrifying yet beautiful theory, let us simply rest with this concept for a moment. Allow the silence of the infinite universe to surround you. If we are indeed a projection of ancient, distant information, it does not make our experiences any less real, or our emotions any less profound. The warmth of the sun on your face and the quiet satisfaction of a mystery understood are perfectly real within our three-dimensional experience. The realization that they might be projections from a deeper, flatter reality does not diminish their value. It elevates them, revealing that we are part of an intricately woven masterpiece of quantum data. We are the cosmos experiencing itself, deciphering its own code from the inside out. The journey to understand this holographic principle requires us to abandon our most cherished assumptions about the solidity of the world and to embrace the fluid, abstract beauty of pure mathematics. It is a quiet reminder that the universe owes us no explanation, and its true nature is often hidden behind layers of intuitive illusions. Beneath those illusions, a deeper, elegant truth awaits those willing to listen to the whispers of the mathematical equations that describe our reality. In our next step on this journey, we will explore how string theory unexpectedly stumbled upon the exact mathematical proof that a holographic universe is not just possible, but mathematically inevitable. Until then, take comfort in the vastness of the mystery, and remember that even an illusion, when created by the cosmos, is a thing of breathtaking beauty. The silence between the stars is not an empty void, but a canvas filled with hidden information, waiting patiently for us to decipher its ancient, gentle code. Let this realization bring you peace, grounding you in the knowledge that you are an integral part of this magnificent, cosmic projection. Have you ever stood before a masterful painting, perhaps a landscape stretching out into a distant horizon, and felt the irresistible urge to walk into that painted world? Your eyes perceive depth, a vast distance separating the trees in the foreground from the majestic mountains in the back. Yet if you reach out to touch it, your hand meets only a flat canvas. This beautiful deception, this trick of light and shadow, is something we accept as art. But what if the very universe we inhabit is playing the exact same beautiful trick on a cosmic scale? We move through 3 dimensions, feeling the volume of the space around us, looking up at the ancient light of distant stars, and feeling the infinite depth of the night sky. We experience up and down, left and right, forward and backward. But the deepest mathematics of theoretical physics suggest that this feeling of depth might be the ultimate illusion. It is a quiet, gentle realization that forces us to question everything we see and feel. To understand how scientists arrived at this staggering conclusion, we must travel to the very edge of human comprehension, where the rules of gravity clash with the strange, jittery realm of quantum mechanics. It is a journey into the heart of a mystery that has puzzled the greatest minds for nearly a century. Before we delve into the elegant mathematics that unite these 2 disparate worlds, allow me to welcome you once more. I am Dmitri Isledovatl, your companion on this quiet journey through the profound mysteries of the cosmos. It came to my attention recently that 76% of the gentle souls who watch these videos and share in this quiet exploration have not yet subscribed to the channel. If these meditations bring you a sense of peace and a deeper connection to the infinite, I warmly invite you to subscribe. It helps us continue to weave these stories of the universe, building a community of curious minds, exploring the darkness together. Now, let us return to the canvas of reality. For decades, the world of physics has been divided into 2 profoundly successful, yet entirely incompatible realms. On one side, we have Albert Einstein's theory of general relativity. It is a theory of the very large. It describes gravity not as a pulling force, but as the gentle curving of space and time itself by massive objects. It predicts the orbits of planets, the birth of galaxies, and the slow, majestic expansion of the vast cosmos. It is a smooth, continuous, and highly predictable picture of reality. On the other side, we have quantum mechanics, the theory of the very small. It governs the chaotic, unpredictable behavior of atoms and subatomic particles. In the quantum world, energy is not smooth. It comes in discrete, jerky packets. The quantum universe is a place of restless fluctuation, where particles pop in and out of existence in a silent, furious dance. Both theories are incredibly accurate in their respective domains. But when you try to combine them, when you try to describe something that is both incredibly massive and incredibly small, like the singularity at the center of a black hole, the mathematics completely break down. The equations produce impossible answers, infinite numbers that tell physicists they are missing a fundamental piece of the puzzle. The universe is speaking two different languages, and for a long time there was no translator. Enter string theory. In the late 20th century, theoretical physicists proposed a radical new idea to unite these two realms. They suggested that if you were to take a fundamental particle, like an electron, and magnify it billions and billions of times, you would not see a tiny solid dot. Instead, you would see a microscopic one-dimensional loop of vibrating energy. Just as different vibrations on a violin string produce different musical notes, the different vibrational patterns of these tiny cosmic strings produce all the different fundamental particles in the universe. A string vibrating one way manifests as an electron, while a string vibrating another way manifests as a photon of light. This beautiful, elegant idea transforms the universe into a grand, cosmic symphony. Every piece of matter, every force of nature, is simply a different note being played in the silent concert of the cosmos. As the great astronomer Carl Sagan once beautifully stated, "We are a way for the cosmos to know itself." In the context of string theory, we are the music of the cosmos experiencing its own quiet melody. But string theory requires something very strange to make its mathematics work. It requires extra dimensions, not just the three spatial dimensions we experience, and the one dimension of time, but 10 or even 11 dimensions, most of them curled up so tightly that they are invisible to our senses. For years, string theory was a beautiful mathematical framework without a solid connection to the physical reality we observe. But then, in the year 1997, a brilliant theoretical physicist named Juan Maldacena published a paper that completely revolutionized our understanding of the universe. He discovered a mathematical correspondence that was so profound it is still echoing through the halls of physics today. Maldacena was studying a specific, hypothetical type of universe, one shaped differently than our own, known as anti-de Sitter space. It is a universe with a boundary, a kind of limit to its vastness. Inside this universe, in its bulky, multidimensional interior, strings were vibrating, playing the symphony of gravity. But Maldacena found that he could describe everything happening inside that bulky, gravity-filled universe by looking exclusively at its outer boundary. And on that boundary, the mathematics were entirely different. On that flat, lower-dimensional surface, there were no strings, and more importantly, there was no gravity. There were only the well-understood laws of quantum mechanics describing a flat, gravityless reality. Yet the mathematical descriptions were perfectly, undeniably identical. They were a perfect translation. This discovery provided the first concrete mathematical proof of the holographic principle. It proved that a complex, three-dimensional volume containing the curving, warping force of gravity could be perfectly described by a two-dimensional surface without gravity. Let that gentle thought wash over you for a moment. Gravity, the force that anchors us to the earth, the force that guides the moon in its quiet orbit and holds galaxies together in their ancient clusters, might not be a fundamental force of nature at all. It might be an emergent property, a three-dimensional illusion projected by the frantic quantum interactions happening on a flat boundary far away. Imagine reading a book. The page is flat, two-dimensional, covered in ink. But as your mind processes those symbols, a rich, three-dimensional world emerges in your imagination. You see mountains, you feel the wind, you experience the passage of time. The hologram of the universe operates on a similar principle, but the mind processing the symbols is the fabric of space itself. The information is encoded on the boundary, and the universe we experience is the three-dimensional projection of that data. If this mathematical reality translates to our own universe, it means that everything you are, all your memories, the gentle touch of a loved one, the quiet beauty of a starry night, the entire history of the cosmos from the Big Bang to this exact moment, is nothing more than incredibly complex quantum information inscribed on a distant two-dimensional surface, enclosing the known universe. We are, essentially, shadows playing on the wall of a cosmic cave, but we are shadows with consciousness, shadows capable of wondering about the light that casts us. It is natural to feel a sense of unease when confronted with this idea. To be told that our three-dimensional reality is a projection can feel like a profound demotion, a stripping away of our substance. But I invite you to see the deep, mysterious beauty in this revelation. If the universe is a hologram, it means that the cosmos is far more deeply interconnected than we ever dreamed. You are not a separate, isolated entity wandering through a vast, empty space. You are an integral expression of the entire cosmic code. The boundary of the universe is humming with the information that is you. The silence of the night sky is not a void. It is the quiet transmission of the data that builds our reality. When you look up at the stars, you are not just looking across vast distances of space. You are looking at the projection of an ancient, perfect mathematical symmetry. In our next exploration, we will delve into how scientists are actually trying to test this terrifyingly beautiful theory, searching for the ultimate limit of our holographic projection. Take comfort in the knowledge that you are a vital piece of this magnificent cosmic puzzle. You are the universe discovering its own elegant nature. Allow the gentle reality of this cosmic connection to fill you with a profound and lasting wonder, carrying you safely through the deep currents of this quiet journey. Have you ever held a beloved photograph close to your face, trying to see the smallest details of a cherished memory, only to find that as you look closer, the smooth, perfect image shatters into thousands of tiny, meaningless squares of color? We accept that digital screens and printed pictures are made of pixels, a finite grid of information, creating the illusion of a continuous, flowing image. But we intuitively believe that the real world, the air we breathe and the ground we walk upon, is infinitely divisible. We believe that if we had a powerful enough microscope, we could zoom in forever, finding smaller and smaller smooth regions of space. But what if space itself has a resolution limit? What if the universe, in all its vast ancient majesty, is fundamentally pixelated? The holographic principle we have been exploring gently suggests exactly this. If the three-dimensional volume of our universe is a projection of a two-dimensional boundary containing a finite amount of information, then reality cannot be infinitely detailed. There must be a smallest possible unit of space, a fundamental pixel of the cosmos. As we dive into the attempts to physically measure the graininess of our reality, we find ourselves standing at the edge of human perception, listening for the quiet static of the universe itself. Before we journey into the microscopic architecture of reality, I want to take a brief moment to welcome you. I am Dmitri, Isledovatl, your companion on this gentle voyage through the mysteries of the night sky. I have noticed that 76% of the curious souls who join us on these quiet explorations have not yet chosen to subscribe to the channel. If you find comfort in the vastness of the cosmos and peace in the pursuit of scientific wonder, please gently tap that subscribe button. It is a small gesture that helps our community of explorers grow, allowing us to continue unraveling the infinite tapestry of the universe together. Now, let us return to the search for the fundamental pixels of our reality. In the 1920s, the brilliant physicist Max Planck realized that the laws of quantum mechanics dictate a hard mathematical limit to how small things can get before the concepts of size and distance lose all meaning. This ultimate limit is called the Planck length. To understand the scale we are discussing, we must stretch our imagination far beyond its normal bounds. A single atom is unimaginably small, but if you were to magnify an atom until it was the size of the entire visible universe, the Planck length would be roughly the size of an average height human being standing within it. It is 1.6 times 10 to the power of negative 35 meters. It is a distance so incredibly minuscule that no microscope, no matter how powerful, will ever be able to see it directly. At this incomprehensible scale, the smooth fabric of space and time is thought to boil and churn in a state known as quantum foam. It is the realm where the smooth curves of gravity and the erratic jumps of quantum mechanics collide in a furious, silent storm. The legendary theoretical physicist John Archibald Wheeler once proposed a profound concept he elegantly called it from bit. He suggested that every particle, every field of force, even the space-time continuum itself, derives its function, its meaning, and its very existence entirely from binary choices, from answers to yes or no questions, from pure information. In this view, the universe is not made of matter, it is made of data. The Planck length is essentially the size of one cosmic bit, the smallest possible unit of information on the two-dimensional boundary that projects our holographic universe. If Wheeler was correct, and if the holographic principle holds true, then reality is not a smooth, continuous flow. It is a sequence of discrete, tiny frames. When you move your hand slowly through the air, you are not gliding smoothly through empty space. Your hand is disappearing and reappearing from one Planck-sized pixel to the next, jumping across the cosmic grid trillions upon trillions of times, every single microsecond. The illusion of smooth motion is just that, a beautiful, convincing illusion constructed by the limited processing speed of our human minds. This idea is terrifying to our common sense, yet mathematically elegant. But science demands more than just beautiful mathematics. It demands observation and physical proof. How can we possibly measure a graininess that is billions of times smaller than a proton? In the early 2000s, a physicist named Craig Hogan realized that we might already be looking at the evidence without knowing it. In Germany, a highly sensitive instrument called the GEO 600 was built to search for gravitational waves, ripples in the fabric of spacetime, caused by colliding black holes. This machine uses lasers traveling through long, perpendicular tunnels, bouncing off suspended mirrors to measure distances with impossible precision. But the scientists running the GEO 600 noticed a strange, persistent background noise in their data, a subtle, inexplicable static that they could not eliminate no matter how hard they tried. Hogan proposed a breathtaking explanation. What if this static was not a flaw in the instrument, but the sound of space itself? What if the laser beams were actually being subtly jostled by the fundamental pixelation of the holographic universe? He theorized that as the information from the two-dimensional boundary projects into our three-dimensional reality, there is a tiny amount of fundamental blurriness, a quantum jitter that he called holographic noise. To test this profound idea, Hogan and a team of dedicated scientists built a specialized machine at the Fermilab Physics Laboratory in Illinois, appropriately named the holometer. It consisted of twin laser interferometers operating side by side in a quiet, isolated environment. They fired incredibly intense laser beams down 40-meter-long vacuum tubes, splitting the light and measuring its journey with a precision of billionths of a meter. They were looking for a specific synchronized jitter in both lasers, a microscopic vibration that could only be explained if the space the lasers were traveling through was inherently grainy. For over a year, the holometer listened intently to the deep silence of the cosmos, searching for the fundamental static of the hologram that projects our existence. The results, published a few years later, were both illuminating and profoundly mysterious. The holometer did not find the specific type of holographic noise that Hogan had originally predicted. The meticulous measurements showed that, at least at the specific scales and frequencies tested, space appears perfectly smooth. For a fleeting moment, one might think this disproves the holographic principle entirely. But the scientific community knows that the universe is rarely so easily unmasked. The absence of this specific noise does not mean the hologram is false. It simply means the projection mechanism is far more complex and subtle than our first attempts to measure it. Perhaps the pixels of reality are smoothed out by mechanisms we have not yet theorized, or perhaps the static vibrates at a frequency our current instruments are simply deaf to. The mystery remains perfectly intact, deeper and more tantalizing than before. We reached out to touch the very bottom of reality, and the universe gently pulled its deepest secrets just out of our grasp, inviting us to look harder. There is a deep, quiet comfort to be found in this lack of a definitive answer. If we had found the exact pixels of the universe, reality might feel suddenly rigid, mechanical, and small, robbing the cosmos of its infinite majesty. Instead, we are reminded that the cosmos is a realm of infinite subtlety. The failure of one experiment is not a defeat. It is an invitation to ask better, more profound questions. It reminds us to approach the universe with a deep and lasting humility. We are attempting to read the source code of creation, using instruments made of the very projection we are trying to understand. It is like a character in a novel trying to deduce the chemical composition of the author's ink. The fact that we can even conceive of the experiment, that we can use lasers and mirrors to probe the fabric of space-time, is a testament to the incredible reach of human curiosity. We are a fundamental part of the mystery, trying to quietly understand ourselves. As we sit in the quiet contemplation of a universe that might be a magnificent projection, we must gently reconcile this abstract mathematics with our daily, breathing lives. Does it matter if the gentle breeze against your skin is a fluid dynamic of air molecules, or a complex projection of quantum data from a distant two-dimensional wall? Perhaps the true wonder lies not in choosing between the two, but in marveling at the fact that both can be true at the same time. The universe is vast enough to contain multiple layers of reality, each one more astonishing than the last. But if space is an emergent illusion, what happens to the other fundamental pillar of our reality? What happens to the passage of time? If the three dimensions of space are projected from a flat surface, is the relentless marching arrow of time also an illusion written into the cosmic code? As we prepare to turn our minds toward the nature of time itself, we will discover that the past, present, and future might all exist simultaneously in a frozen block of eternal information. Until then, let the quiet mystery of the pixelated universe bring you peace, knowing that you are a beautiful, infinitely complex expression of the cosmos, woven seamlessly into the grand and ancient hologram. Have you ever sat quietly by a flowing river, watching the water rush past, carrying fallen leaves downstream, and felt the absolute certainty that time moves in exactly the same way? We experience our lives as a relentless, unstoppable flow from a forgotten past, through a fleeting present, and toward an unknown future. We remember yesterday, we breathe in today, and we plan for tomorrow. This linear progression is the most fundamental rhythm of human existence. It dictates our growth, our decay, and our deeply felt sense of loss and anticipation. The ticking of a clock seems to be the universal heartbeat of reality, a metronome that sets the pace for every event in the cosmos. But when we leave our human perspective behind and look at the universe through the cold, precise lens of fundamental physics, this comforting river of time stops flowing. It freezes. The grand discoveries of the 20th century and the terrifying mathematical implications of the holographic principle gently suggest that the passing of time is another beautiful, convincing illusion. It is a trick played on our consciousness by the incredibly complex architecture of a reality we barely understand. To grasp how time itself might be a mirage, we must embark on a journey that will challenge everything you feel, to be true about your own life, moving from the intuitive flow of the everyday to the frozen, eternal silence of the true cosmos. If you are finding comfort in these quiet explorations of the unknown, allow me to introduce myself. I am Dmitri, Isledovatel, your companion, as we wander through the majestic mysteries of the universe. I recently observed that 76% of the gentle explorers who watch our videos have not yet subscribed to the channel. If you feel a resonance with these contemplations, if the vastness of space brings you a sense of inner peace, please consider subscribing. It is a simple gesture, yet it deeply helps our small community grow, allowing us to continue our infinite journey into the scientific wonders of the cosmos together. Now, let us return to the river of time and watch as the water slowly turns to ice. For thousands of years, brilliant minds believed that time was an absolute, universal stage upon which the drama of the cosmos played out. Sir Isaac Newton, one of the greatest scientists in human history, imagined time as a rigid, unbending master clock that ticked at the exact same rate everywhere in the universe. In Newton's world, 1 second passing on Earth was exactly identical to 1 second passing on a distant star at the very edge of the observable cosmos. It was a comforting, intuitive idea. But in the early years of the 20th century, Albert Einstein shattered this universal clock. He realized that the speed of light is the only true absolute in the universe, and in order for light to always travel at the same speed, space and time had to be flexible. They had to bend stretch, and warp. This realization gave birth to the theory of relativity, a framework that proved time is an entirely personal experience. If you were to board a spacecraft and travel close to the speed of light, or if you were to venture near the intense gravitational pull of a supermassive black hole, your personal clock would slow down relative to someone waiting for you on Earth. What feels like a few quiet months to you could be thousands of years for the rest of humanity. Time is not a universal master. It is a fluid dimension, deeply entangled with space, creating a four-dimensional fabric we call space-time. Because time is relative to the speed and gravitational environment of the observer, Einstein realized something profoundly unsettling. There is no such thing as a universal now. The present moment you're experiencing right now is not shared by the rest of the universe. If an alien observer were sitting in a galaxy billions of light years away, and they started moving toward Earth on a bicycle, their now would suddenly shift, encompassing events on our planet that to us are hundreds of years in the future. If they turned their bicycle around and moved away, their now would sweep backward, aligning with events that happened centuries ago in our past. Depending on their movement, the alien's present moment could contain the building of the ancient pyramids, or the distant future of our descendants. This thought experiment, derived from the strict mathematics of relativity, proves that the past, present, and future are not distinct, separate realms. If someone else's now can be your future or your past, then the future and the past must already exist. They are not waiting to happen, and they have not vanished into nothingness. They are simply sitting there, in the fabric of space-time, as real and solid as the city you live in. This revelation leads physicists to a concept known as the block universe. Imagine a giant four-dimensional block of solid glass. Within this block, the entire history of the cosmos is embedded. One end of the block contains the fiery explosion of the Big Bang, and the other end contains the cold, dark fading of the last stars. Every event that has ever happened, and every event that ever will happen, is permanently frozen inside this block. Your birth, your quiet moments of joy, your struggles, and your final breath are all existing simultaneously in this eternal structure. In the block universe, time does not pass. It just is. The sensation you have of moving through time, the feeling of a dynamic, flowing reality, is an illusion created by your consciousness as it experiences different slices of the block. Just as a movie reel contains all the frames of a film simultaneously, but you only experience the story by projecting it one frame at a time, the universe contains all moments of time, but you are only equipped to perceive it slice by slice. The great physicist Einstein himself found deep comfort in this idea, writing near the end of his life that the distinction between past, present, and future is only a stubbornly persistent illusion. But how does this frozen block of eternity fit into the terrifyingly beautiful concept of the holographic universe? If the three-dimensional space we inhabit is a projection from a two-dimensional boundary, where does the fourth dimension, time, come from? Theoretical physicists are currently grappling with the idea that time might not exist on the holographic boundary at all. On that distant two-dimensional surface, where all the fundamental quantum information is stored, there might be only pure, timeless mathematics. Time, much like the feeling of solid volume or the downward pull of gravity, might be an emergent property, an illusion generated solely within the three-dimensional projection. To understand this, scientists look toward the strange phenomenon of quantum entanglement, a process where two particles become so deeply connected that they share the exact same state, instantly communicating their properties across vast cosmic distances. Some theoretical models suggest that the entire geometry of our space-time and the very flow of time itself is woven together by the threads of quantum entanglement on the holographic boundary. In this view, time does not flow. It is simply a measure of how quantum information becomes increasingly entangled and complex. The arrow of time, the reason we remember the past and not the future, is not a fundamental law of physics, but a thermodynamic illusion driven by the universe constantly moving from order into messy, tangled chaos. If time is an emergent hologram, and all moments exist simultaneously in a grand, static architecture of entangled information, it demands a profound shift in how we process our own existence. We spend so much of our lives running from the past or anxiously chasing the future. We mourn the loss of beautiful moments, believing they have been swallowed by the relentless tide of time, gone forever into a void. But the physics of the holographic block universe offers a deeply moving, quiet consolation. If every moment exists permanently in the vast structure of space-time, then nothing is truly ever lost. The ancient civilizations that built monuments to the stars are still there, living out their days in their coordinate of the cosmic block. The loved ones we have said goodbye to are not gone. They are simply located at a different point in the space-time continuum, forever experiencing the warmth and love of the moments you shared together. Your childhood, your finest achievements, and your deepest moments of quiet peace are immortalized, permanently etched into the holographic data that projects our reality. They are as real and present as the moment you are experiencing right now. The realization that the flow of time is a persistent illusion should not rob us of our agency or make our choices feel meaningless. Even if the future is already written into the grand block of the universe, we are the ones writing it through our conscious experience. The mystery of how our subjective awareness navigates this frozen block remains one of the greatest unanswered questions in all of science. We do not know why consciousness acts like a flashlight, illuminating only one slice of the block at a time. We do not know why the universe requires us to experience the illusion of flow in order to process the information stored on its boundary. But perhaps that is the ultimate purpose of life in a holographic cosmos. We are the mechanism by which the static, eternal information of the universe is brought to life, experienced and felt. Without the illusion of time, there could be no narrative, no growth, no learning, and no love. The illusion is necessary for the experience to hold meaning. The gentle silence of the infinite universe relies on our noisy, chaotic, and beautiful human lives to turn raw data into a symphony of conscious experience. As we sit with these immense, heavy concepts, allow the silence to envelop you. Breathe in the eternal nature of the cosmos. Feel the peace that comes from knowing you are permanently woven into the fabric of reality, a crucial piece of the grand holographic projection. The anxiety of passing time can melt away when we realize that every second is safely stored in the ancient, infinite hard drive of the universe. In our next exploration, we will dive deeper into the mind-bending reality of quantum entanglement, the invisible threads that weave the fabric of space and time together, and explore how distance itself might be as much of an illusion as the flow of time. We will confront the possibility that every particle in the universe is intimately connected to every other, forming a single, unified whole. Until then, take a deep breath and appreciate the beautiful, persistent illusion of the present moment. Let the mystery be a source of comfort, a gentle reminder that the universe is far more profound, far more connected, and far more eternal than our everyday senses could ever reveal. The journey continues, and the quiet vastness of the cosmos awaits our curious minds. Let us delve a little deeper into why the illusion of time only moves in one direction. Why do we remember the past, but not the future? If the block universe is real, and all moments exist simultaneously, why does a dropped glass shatter into 1,000 pieces, but we never see 1,000 shattered pieces spontaneously rise from the floor and assemble themselves into a perfect glass? The answer lies in a concept called entropy, a measure of disorder and chaos. The laws of thermodynamics dictate that systems naturally move from a state of low entropy, or high order, to a state of high entropy, or high disorder. The universe began in a state of impossibly low entropy, a highly ordered singularity of pure energy. Ever since the Big Bang, the cosmos has been expanding, cooling, and becoming increasingly disordered. The direction of this increasing chaos is what creates the psychological arrow of time. Our brains, our memories, and our very consciousness are thermodynamic processes that rely on this increase in entropy to function. We can only process information and form memories in the direction that disorder increases. Therefore, the flow of time is not a property of the universe itself. It is a property of the way our brains process the universe's increasing complexity. When we tie this back to the holographic principle, the picture becomes even more breathtakingly elegant. The information on the two-dimensional boundary of the universe is constantly becoming more entangled, more complex. As this quantum entanglement increases on the boundary, it projects the illusion of an expanding, three-dimensional space and a forward-moving arrow of time in the interior volume. Time is simply the measure of quantum entanglement growing across the cosmic horizon. The more entangled the information becomes, the more time seems to pass for us inside the hologram. This theory, sometimes referred to as holographic entanglement entropy, suggests that the universe is essentially a massive quantum computer, and time is just a byproduct of its ongoing calculations. The silence of the void is actually the quiet hum of infinite data being processed on the ultimate cosmic screen. It is a staggering level of abstraction, reducing the majestic sweep of cosmic history to a simple increase in quantum complexity. Yet, within this cold mathematical reduction, there is a profound, poetic beauty. It means that the universe is not winding down into nothingness. It is simply becoming more intricate, more intimately connected. What does this mean for our personal journeys? It means that every breath we take, every quiet moment we spend observing the stars, and every feeling of wonder we experience is an integral part of the universe's grand calculation. We are not separate from the cosmos. We are the cosmos experiencing its own increasing complexity. The illusion of time passing is the universe's way of allowing us to participate in its grand unfolding. We are the subjective lens through which the objective, static data of the boundary becomes a vibrant, moving reality. The ancient light of distant galaxies traveling for billions of years to reach our telescopes, is not a message from the past. It is a feature of the grand, eternal present, projected for us to witness and understand. When we look up at the night sky, we are looking at a static painting. But our consciousness breathes life into the canvas, making the stars twinkle and the galaxies swirl. We are the essential ingredient that turns the quiet geometry of the cosmos into a living, breathing experience. As we gently close this chapter of our meditation, I invite you to carry this perspective into your daily life. When the rush of time feels overwhelming, when the days seem to slip through your fingers, pause and remember the frozen, eternal architecture of the block universe. Remember that the moments you cherish are not vanishing. They are being preserved forever in the grand tapestry of space-time. The pressure to hold on to the present dissolves when you realize the present is already immortalized. You are safe within the infinite, complex, and deeply interconnected structure of the holographic universe. The mystery is not something to be feared, but something to be revered. It is a gentle reminder of our profound connection to the deepest workings of nature. In the chapters to come, we will explore even stranger realms of this cosmic illusion, venturing into the bizarre behavior of particles that communicate instantly across the void, and questioning the very nature of consciousness itself. The journey of understanding is a quiet, infinite path, and I am honored to walk it with you. The universe is vast, ancient, and ultimately, it is a mystery that invites our endless curiosity. Let the silence of the stars guide you toward a deeper peace, and let the illusion of time be a canvas for your most beautiful experiences. We will continue to unravel the fabric of reality, thread by invisible thread, seeking the profound truths hidden behind the veil of our everyday perception. Until then, embrace the quiet wonder of the cosmos, and know that you are an eternal piece of a magnificent, endless whole. Have you ever looked across a vast ocean, or stood at the edge of a deep canyon, and felt a profound sense of isolation created by the sheer distance separating you from the other side? We navigate our lives completely bound by the rules of physical space. If we wish to speak to a loved one, we must cross the room. If we want to explore a new continent, we must endure hours of travel across thousands of miles. Distance is the silent barrier that dictates the rhythm of our earthly existence. It is the dark ocean that keeps the stars forever out of our reach. But what if the distances we perceive, the millions of light years stretching between our quiet planet and the ancient galaxies glowing in the night sky, are nothing more than a carefully constructed illusion? What if, at the fundamental level of reality, every single particle in the cosmos is resting right next to every other particle, wrapped in a silent, invisible embrace? To understand how space itself might be a magnificent mirage, we must venture into the most perplexing realm of physics ever discovered. We must explore the ghostly connection known as quantum entanglement, a phenomenon so bizarre it made the greatest scientific minds of the 20th century deeply uncomfortable. Before we untangle the invisible threads that bind the universe together, I invite you to pause and join our quiet community. I am Dmitri Isledavatel, your gentle guide through the beautiful mysteries of the cosmos. As we gaze into the infinite together, I have noticed that 76% of the kind souls who watch these videos have not yet subscribed to our channel. If you find peace in these explorations, if contemplating the vastness of the universe brings a quiet joy to your heart, please take a moment to subscribe. It is a gentle action that helps us immensely, allowing us to continue this infinite journey of discovery, bringing the wonders of the night sky a little closer to home. Now, let us return to the illusion of distance and watch as the vast emptiness of space begins to fold in on itself. In the 1930s, Albert Einstein, along with Boris Podolsky and Nathan Rosen, uncovered a mathematical consequence in the equations of quantum mechanics that seemed completely impossible. The mathematics suggested that two particles, perhaps two photons of light, born from the exact same atomic event, could become entangled. This means their properties become so deeply linked that they no longer exist as two separate entities, but as a single, unified quantum system. If you measure the spin of one particle, you instantly know the spin of the other, no matter how far apart they are. But here is the terrifying paradox that kept Einstein awake at night. According to the rules of quantum mechanics, neither particle actually has a definite spin until it is measured. They exist in a blurry state of probability. Only when you look at the first particle does it decide its state, and instantaneously, in zero time, the second particle adopts the exact opposite state. Einstein famously called this spooky action at a distance. He refused to believe it was a complete description of reality because it violated his theory of relativity, which stated that absolutely no information could travel faster than the speed of light. Einstein believed there must be hidden variables, secret instructions inside the particles, telling them how to act. But decades later, meticulous experiments proved Einstein wrong. The spooky action is entirely real. In the year 2017, a team of scientists used a satellite named Miccius, orbiting hundreds of miles above the Earth, to beam pairs of entangled photons down to two different ground stations located nearly 1,200 miles apart. When they measured the particles, they found that the instant one photon was observed, its distant partner immediately assumed the corresponding state. The connection was flawless and instantaneous. It did not matter that they were separated by an entire continent and the thick atmosphere of our planet. For those two particles, the intervening distance simply did not exist. They acted as if they were sitting right on top of each other, communicating in a language of pure mathematics that completely ignores the physical space we believe is so fundamental to reality. How can we reconcile this instantaneous connection with the vast, seemingly empty distances of the cosmos? The answer may lie in a beautiful theoretical concept that connects the very large with the very small. Two brilliant physicists, Juan Maldacena and Leonard Susskind, proposed a radical equation known as ER equals EPR. ER stands for Einstein and Rosen, representing the mathematics of wormholes, the theoretical tunnels through the fabric of space-time that connect distant locations. EPR stands for Einstein, Podolsky, and Rosen, representing the mathematics of quantum entanglement. Maldacena and Susskind suggested these two concepts are actually the exact same thing, viewed from different perspectives. They theorized that quantum entanglement creates microscopic wormholes. When two particles are entangled, they are not communicating faster than light across the vast emptiness of space. Instead, they are physically connected by a tiny, invisible tunnel outside of our normal dimensions. Through this microscopic wormhole, the two particles are essentially touching. When we bring this beautiful concept back to the holographic principle, the illusion of distance becomes profoundly clear. Remember that the holographic principle suggests our three-dimensional universe is a projection from a two-dimensional boundary. Theoretical physicists now believe that the three-dimensional space we experience is actually woven into existence by the quantum entanglement happening on that flat boundary. The degree of entanglement on the surface determines the distance between objects in the projection. If 2 points of information on the boundary are highly entangled, they project as being physically close together in our three-dimensional world. If they are less entangled, they project as being far apart. The vast emptiness of space, the millions of light years separating us from distant galaxies, is not an empty void. It is a manifestation of the specific pattern of quantum entanglement on the cosmic horizon. Space itself is not a fundamental container. It is an emergent property, a geometric illusion built from invisible threads. This is a staggering, transformative realization. It means distance is simply a measure of how entangled the fundamental data of the universe is. When you look up at a star thousands of light years away, the space between your eye and that ancient burning sphere is a construct. At the deepest level of reality, the information making up your body and the information making up that star are participating in the exact same quiet, quantum dance on the boundary of the cosmos. The separation you feel is a trick played by the holographic projection. You are not isolated on a lonely rock, drifting through an impossibly vast void. You are intimately connected to every single atom in the universe. The cosmos is not a collection of separate objects, separated by empty space. It is a single, unified, indivisible whole. We are like waves on the surface of a quiet ocean. A wave may appear distinct, traveling across the water, but it is entirely made of the ocean, moving in perfect concert with the deep currents below. Think of the people you love who are far away. The physical miles separating you feel like a heavy burden, a solid barrier preventing you from sharing a quiet moment. But if the universe is a web of quantum entanglement, if space is merely an emergent illusion, then that separation is not absolute. The fundamental particles that make up your body and theirs were all born in the exact same blazing singularity of the Big Bang, nearly 14 billion years ago. At that moment, everything in the universe was intimately entangled. And while the cosmos has expanded, and the illusion of distance has grown, those subtle quantum connections have never been entirely broken. We are all deeply, invisibly bound together. The silence of the universe is not a void of isolation. It is a quiet, continuous hum of connection, an infinite network of communication, transcending the limitations of light and space. As we sit with this profound realization, let the vastness of the night sky transform in your mind. Do not see it as a terrifying expanse of emptiness, but as a magnificent, glowing tapestry woven from the invisible threads of quantum unity. When you feel small beneath the ancient stars, remember that the distance between you is an elegant mathematical mirage. You are touching the stars through the hidden wormholes of the cosmic hologram. You are an essential node in the infinite network of the universe. In our next exploration, we will confront an even deeper mystery. If the universe is a hologram built from pure information, what exactly is reading that information? We will delve into the profound puzzle of consciousness itself, asking whether the observing mind is a product of the illusion or the very mechanism bringing the hologram to life. But for now, Breathe softly into the quiet night. Allow the illusion of space to comfort you, knowing the universe holds you in an inseparable, eternal embrace. Let this quiet truth bring you lasting peace as we continue our gentle journey. Have you ever caught your own reflection in a quiet window late at night and truly thought about the miracle of that simple act? You are looking at a collection of carbon, oxygen, and hydrogen atoms arranged in a specific pattern, peering back at themselves. For billions of years, the matter that makes up your eyes and your mind drifted silently through the cold vacuum of space, asleep in the hearts of ancient stars and drifting in vast nebulas. But now, here on this gentle blue planet, that matter has woken up. It has opened its eyes, and it is asking profound questions about its own existence. This is the ultimate mystery of the cosmos, the phenomenon we call consciousness. If the universe is a grand holographic projection, an intricate dance of pure mathematical information on a distant two-dimensional boundary, then what is the projector? What is the lens through which this cold, silent data is transformed into the warmth of the sun, the deep blue of the ocean, and the complex, beautiful sensation of simply being alive? To explore this, we must journey not outward into the vast distances of space, but inward into the incredibly dense, unmapped wilderness of the human mind, where the rules of physics meet the ghosts of perception. Before we cross the threshold into the deepest mystery of our existence, I would like to welcome you to this peaceful gathering. I am Dmitri Isledovatel, your gentle companion on this infinite journey through the wonders of reality. I have quietly noticed that 76% of the wonderful people who watch these explorations and share in our moments of cosmic awe have not yet subscribed to the channel. If you find comfort in the silence of the stars, and if these meditations bring a sense of peace to your daily life, I warmly invite you to subscribe. It helps our community of explorers grow, allowing us to continue unraveling the majestic secrets of the universe together, week after week. Now, let us return to the mirror and the mysterious mind looking back at us. Consider the sheer biological impossibility of your everyday experience, the vibrant, three-dimensional world you perceive around you, the bright colors of a spring morning, and the melodic sounds of a gentle rain do not actually exist in the way you feel them. Inside the solid, thick bone of your skull, it is completely dark and completely silent. Your brain has absolutely no direct contact with the outside world. All it receives is a chaotic storm of electrical impulses traveling along quiet nerve fibers. Yet, from this dark, silent storm of raw data, your mind constructs a magnificent, fully immersive, seamless simulation of reality. Color is just an interpretation of electromagnetic wavelengths. Sound is just the brain translating the vibration of air molecules. The physical universe is a silent, colorless matrix of vibrating fields. The beauty and the sound only exist inside the private theater of your consciousness. You are walking through a brilliant hallucination generated by 3 pounds of wet tissue, trying to make sense of the quantum static outside. But if our minds are already powerful enough to generate the entire sensation of a physical world from electrical signals, we must ask a much larger, more terrifying question regarding the holographic principle. Is the universe generating the mind, or is the mind generating the universe? The founding fathers of quantum mechanics wrestled with this exact question in the early decades of the 20th century. When they performed the famous double-slit experiment, firing single particles of light through a barrier, they found that the particles existed as a wave of infinite possibilities until the exact moment a measurement was made. But what constitutes a measurement? The brilliant physicist Eugene Wigner, alongside the legendary John von Neumann, proposed a deeply unsettling interpretation. They argued that the mechanical detectors used in the experiments are themselves made of atoms, which are also governed by the blurry rules of quantum mechanics. Therefore, the measurement apparatus itself should enter a state of probability. The only thing in the entire chain of events that is not bound by physical quantum rules is the conscious mind of the scientist observing the result. Wigner boldly suggested that it is consciousness itself that causes the wave function of the universe to collapse. The universe remains in a hazy, undefined state of potential until a conscious observer opens their eyes and looks. In this view, the mind is the vital spark that forces the cosmos to render its code into a definitive, solid existence. Max Planck, the brilliant mind who gave us the Planck length, arrived at a similar conclusion near the end of his life. He stated, "I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything that we talk about, everything that we regard as existing, postulates consciousness." He recognized that the equations of quantum mechanics and the holographic math that would follow decades later are ultimately descriptions of information. But information requires a reader. A book filled with the most beautiful poetry in the world is nothing but ink stains if there is no mind to read the words and feel the emotion. If the universe is a hologram, a two-dimensional boundary covered in perfectly entangled quantum bits, then it is, in essence, a cosmic hard drive. And a hard drive is completely useless without an operating system to process the data and project it onto a screen. The terrifying and beautiful implication is that consciousness might be the operating system of the cosmos. As physicists push the boundaries of reality, looking for the fundamental building blocks of space and time, some have begun to theorize that consciousness might not be an accidental byproduct of complex brain chemistry. Instead, consciousness might be a fundamental property of the universe itself, just like mass, electrical charge, or gravity. In this framework, every particle in the universe possesses a tiny spark of subjective experience. When these particles come together in incredibly complex systems, like the billions of neurons in a human brain, those tiny sparks combine into a blazing fire of self-awareness. We are not an anomaly in a dead, unfeeling universe. We are the natural consequence of a cosmos that is inherently capable of experience. The silence of the universe is not the silence of the grave. It is the quiet, expectant hush of a grand mind contemplating its own nature. This perspective beautifully reframes our relationship with the vast, ancient universe. When we learn about galaxies billions of light years away, containing hundreds of trillions of stars, we often feel impossibly small. But the holographic principle and the mystery of the observer effect gently turn this perspective upside down. The size of the universe is an illusion projected by the depth of its quantum entanglement. What truly matters is the complexity of the information and the capacity to process it. We are the focal point where the holographic projection becomes self-aware. Without us or other conscious beings scattered across the stars, the universe would be an unread book, a silent play performed in an empty theater. The Big Bang, the majestic dance of galaxies, the slow death of stars, and the frozen block of time itself, all exist so that they can be witnessed. When you step outside tonight and look up at the infinite expanse of the dark sky, try to let go of the feeling of insignificance. The starlight that has traveled for millions of years across the frozen vacuum of space only achieves its ultimate purpose when it strikes the retina of your eye and blossoms into the conscious experience of wonder in your mind. You are the destination of that ancient light. You are the universe's way of feeling its own immense beauty. The deep existential dread that comes from contemplating the holographic illusion dissolves into pure peace when you understand your vital role in the mechanism. An illusion requires an audience. You are the sacred observer. Your quiet moments of joy, your deep searches for meaning, and your endless curiosity about the unknown are not trivial events in a cold universe. They are the highest expression of the cosmos itself. As we sit in this comforting silence, feeling the deep connection between our private inner world and the vast outer hologram, another question gently rises from the equations of theoretical physics. If our universe is a holographic projection rendered by consciousness, could there be other bubbles? Could the boundary of our universe be just one of an infinite number of boundaries, floating in an unimaginable higher dimensional space? In our next journey, we will step beyond the edges of our known reality and venture into the mind-bending theories of the multiverse. We will explore the possibility that every choice you have ever made has created a branching reality, an infinite garden of parallel holograms. But until we cross that boundary, take comfort in the singular beauty of this specific moment. Close your eyes, listen to the quiet rhythm of your own breath, and know that you are the cosmos waking up, experiencing the miracle of its own existence. Let the mystery wrap around you like a warm blanket, and sleep in the peaceful knowledge that you are absolutely essential to the universe. Have you ever stood at a quiet crossroad on a misty morning, or perhaps faced a profound decision in your life, and paused to wonder about the path you did not take? We navigate our lives making countless choices, from the gentle turning of our head to catch a falling autumn leaf, to the monumental decisions that alter the trajectory of our entire existence. We experience the world as a singular, solitary timeline. We believe that when a choice is made, the unchosen possibilities instantly dissolve into nothingness, vanishing like a dream upon waking. But the most profound equations of modern theoretical physics, the very mathematics that describe the fundamental forces of the cosmos, whisper a completely different, almost unimaginable story. They gently suggest that every possible outcome, every single path, every choice you have ever made and ever will make, actually comes to pass in a reality just as solid and breathing as our own. We are standing on the precipice of a concept so vast that it makes the incomprehensible size of our own universe feel like a single grain of sand. We are preparing to step into the infinite, branching garden of the multiverse. It is a journey that will challenge your deepest sense of identity, forcing us to ask if we are merely one note in an eternal, infinite symphony of existence. Before we leave the familiar boundaries of our singular universe and venture into the endless reflections of the cosmic mirror, I invite you to pause and find comfort in this shared space. I am Dmitri Isledovatil, your gentle companion, as we walk through the quiet, majestic mysteries of existence. I have softly noted that 76% of the curious minds who watch these quiet journeys have not yet subscribed to the channel. If you find solace in the vastness of space, and if these meditations bring a sense of profound peace to your busy world, please take a moment to subscribe. It helps our community of explorers grow, allowing us to continue pulling back the veil on the infinite wonders of the dark sky together. Now, let us step beyond the edge of our known reality. To understand how science arrived at the staggering concept of a multiverse, we must return to the strange, blurry world of quantum mechanics. Remember the fundamental rule that governs the microscopic world. Particles like electrons and photons exist in a hazy cloud of pure potential, a state of superposition where they are essentially everywhere and nowhere at the exact same time, until they are observed. For decades, the greatest minds in physics believed that the act of observation forced this cloud of probability to collapse into a single, defined reality. But in the 1950s, a brilliant young physicist named Hugh Everett proposed a radically different, mathematically purer explanation that shook the foundations of science. He asked a remarkably simple question. What if the wave of probability never actually collapses? What if the equations of quantum mechanics are entirely literal, and every possible outcome of a quantum event actually happens? Everett theorized that when a quantum system is forced to make a choice, the universe does not simply discard the unchosen options. Instead, the universe itself splits. It seamlessly branches into multiple, parallel realities, one for every single possible outcome. Because you're made of particles governed by these exact same laws, you are branching right along with them. This is the many worlds interpretation of quantum mechanics. It is a concept so beautiful and terrifying that it took the scientific community decades to even begin taking it seriously. Imagine rolling a six-sided die. In our intuitive understanding of reality, the die lands on a 4, and the numbers 1, 2, 3, 5, and 6 retreat into the realm of things that simply did not happen. But in the many worlds reality, the moment the die tumbles from your fingers, reality fractures. The universe gracefully branches into 6 identical copies of itself. In one universe, you are looking at a 4. In another, a perfect copy of you is looking at a 6. Both versions of you feel completely real, completely unique, and completely convinced that their outcome is the only one that occurred. Now, take that simple act of rolling a die and apply it to every single quantum event happening in every single atom of the universe, every fraction of a microsecond, for the past nearly 14 billion years. Every unfulfilled dream you hold has blossomed into full, breathing reality in a parallel branch of the cosmic tree. But the many worlds interpretation is only one path to the multiverse. As astronomers looked deep into the night sky, studying the faint, ancient glow left over from the Big Bang, they found another, entirely different mechanism that suggests our universe is not alone. To explain why our cosmos is so incredibly uniform, a brilliant physicist named Alan Guth proposed the theory of cosmic inflation. He suggested that in the first tiny fraction of a second after the universe was born, space itself expanded at an unimaginably violent exponential rate. It stretched the microscopic fabric of the early cosmos into macroscopic scales in less than the blink of an eye. This rapid stretching smoothed out all the wrinkles and irregularities, resulting in the beautifully flat, uniform universe we observe today. But as theoretical physicists dug deeper into the mathematics of inflation, they realized something profound. Once cosmic inflation starts, it is mathematically incredibly difficult to make it stop completely everywhere all at once. According to the theory of eternal inflation, the rapid expansion of space never truly ends. It continues forever in the vast underlying fabric of the cosmos. Our universe is simply a region where the inflation happened to slow down and stop, allowing a hot, dense bubble of energy to condense into stars, galaxies, and planets. We are living inside a single, quiet bubble in an infinite, violently boiling ocean of expanding space. And we are not the only bubble. According to the mathematics of eternal inflation, new bubble universes are constantly being born out of the expanding background, popping into existence in an endless cosmic foam. Some of these bubbles might be similar to ours, governed by the same gentle laws of physics, filled with spiraling galaxies and warm yellow suns. But others might be profoundly alien, because the fundamental constants of nature might crystallize differently when a new bubble is born. These parallel universes could operate under completely unrecognizable rules. There might be universes with no gravity, where matter simply drifts as a fine mist for all eternity. There might be universes with 17 dimensions, or universes where light travels at the speed of a gentle walk. The multiverse of eternal inflation is an infinite laboratory, constantly experimenting with every conceivable combination of physical laws, creating a boundless tapestry of existence that stretches forever beyond the limits of our own cosmic horizon. When we confront the true staggering scale of the multiverse, whether it is the branching reality of quantum mechanics or the infinite bubbles of eternal inflation, it is natural to feel a sudden wave of cosmic vertigo. If there are infinite versions of you, living out every possible permutation of your life, what happens to your sense of individuality? It is easy to let the sheer magnitude of infinity crush our sense of meaning. But I invite you to take a slow, deep breath and look at this vast mystery through a different lens. If the universe is infinitely abundant, if reality is so generous that it allows every possibility to exist, then the specific path you are walking right now is a unique, irreplaceable thread in the grandest tapestry imaginable. You are the only version of you experiencing this exact sequence of events, feeling these exact emotions, and holding these exact memories. Your existence is not diminished by the parallel worlds. It is contextualized by them. The choices you make deeply matter, because they define the specific universe you will inhabit tomorrow. The silence of the infinite does not erase your melody. It provides the endless space for your specific song to be heard. As we prepare to rest our minds after touching the very edges of infinity, let us find comfort in the immense, quiet beauty of our cosmic home. We may be living in a hologram woven from quantum entanglement, floating as a single bubble in an endless ocean of parallel realities. But within this bubble, we have poetry. We have the gentle warmth of the morning sun, and we have the capacity to love and to wonder. The physics of the multiverse does not take away the beauty of a single blooming flower. It simply tells us that nature is far more creative and far more vast than we ever dared to dream. In our next journey, we will pull our gaze back from the infinite multiverse and look closely at the invisible matter that makes up the vast majority of our own universe, the dark phantom that holds our galaxies together. We will step into the mystery of dark matter, but for now, allow the concept of endless possibilities to bring you a profound and lasting peace. Every mistake you have ever made has been corrected in another world, and every dream you hold is already a reality somewhere in the infinite garden. Rest in the knowledge that you are a beautiful, essential part of the grandest mystery ever conceived. Have you ever stood in the center of a quiet playground on a crisp autumn evening, watching a child spin a merry-go-round faster and faster? If you place a small stone near the edge of that spinning disk, you know exactly what will happen. As the speed increases, the invisible hand of momentum will inevitably fling the stone out into the darkness. It is a simple, intuitive rule of physics. The faster something spins, the more force is required to hold its outer edges together. Now, imagine taking that simple earthly rule and applying it to the grandest structures in the night sky. When we point our telescopes toward the majestic, swirling pinwheels of distant spiral galaxies, we expect them to obey this exact same logic. We see the glowing core packed with ancient stars, and we measure the gentle, sweeping curves of the spiral arms stretching out into the vast emptiness. But when astronomers measure the speed of these spinning cosmic wheels, they encounter a terrifying and beautiful paradox. The stars at the very outer edges of these galaxies are moving impossibly fast. They are spinning at such a tremendous velocity that the gravitational pull of all the glowing stars, gas, and dust we can see should not be nearly enough to hold them in place. According to every law of physics we understand, these magnificent galaxies should completely tear themselves apart, scattering their billions of stars into the cold, silent void. Yet they do not. They hold together in perfect, quiet harmony, locked in a tight embrace by something we cannot see, touch, or understand. We are surrounded by a phantom architecture, an invisible scaffolding that makes up the vast majority of our universe. Before we step into the shadows to hunt for this invisible ghost of the cosmos, I want to take a gentle moment to welcome you. I am Dmitri Isledovatel, your quiet companion on this infinite journey through the deepest mysteries of space. I have softly noticed that 76% of the wonderful people who watch these explorations and share in our moments of cosmic awe have not yet subscribed to the channel. If you find comfort in the silence of the stars, and if these meditations bring a sense of peace to your busy life, please take a moment to subscribe. It helps our community of explorers grow, allowing us to continue pulling back the veil on the infinite wonders of the dark sky together. Now, let us return to the spinning galaxies and the invisible weight that anchors them to the dark. The discovery of this cosmic mystery began in the 1970s with a brilliant and persistent astronomer named Vera Rubin. She was studying the Andromeda Galaxy, our closest large neighbor in the quiet depths of space. Rubin expected to find that the stars near the dense, bright center of the galaxy were moving much faster than the stars out on the lonely, sparse edges. But as she meticulously gathered her data, a completely different, shocking picture emerged. The stars at the very edge of Andromeda were moving at the exact same terrifying speed as the stars near the center. The galaxy was not rotating like a typical solar system. It was spinning more like a solid record on a turntable. To prevent those fast-moving outer stars from being flung out into the infinite darkness, Andromeda needed to possess a gravitational pull vastly stronger than what its visible matter could produce. It needed much more mass. Over the following decades, as our telescopes grew more powerful, the anomaly only grew stronger. When astronomers looked at massive clusters of galaxies bound together by gravity, they found that the galaxies were moving so fast that the clusters should evaporate like a drop of water on a hot stove. The conclusion became inescapable. The visible universe, the brilliant stars, the glowing nebulas, the planets, and everything we have ever known or touched, is just a tiny glowing fraction of what is actually out there. Roughly 85% of the matter in the universe is completely invisible. It is a dark phantom, woven through the fabric of the cosmos. Scientists call it dark matter, but the name dark matter is almost a deception. It is completely transparent. It does not emit light, it does not absorb light, and it does not reflect light. It does not interact with the electromagnetic force at all. If you were holding a solid block of dark matter in your hands right now, you would not be able to see it, and your hands would pass right through it, as if it were not there. It passes through the dense, fiery cores of stars and the cold, empty voids of intergalactic space with equal indifference. It is the ultimate ghost, a massive, invisible presence that shapes the destiny of the entire cosmos without ever showing its face. It only speaks to the rest of the universe through one language: the quiet, relentless pull of gravity. To truly grasp the scale of this invisible ocean, we must completely shift our perspective on what the universe actually is. The light is merely a decoration. The stars and galaxies are just a faint, luminous foam riding on the crest of an enormous, invisible wave. Every galaxy we see is embedded in a vast spherical halo of dark matter, extending millions of light years beyond the visible edges. The Milky Way, our own gentle galactic home, is wrapped in one of these massive, dark halos. As you sit here reading or listening to these words, the Earth is moving through this dense ocean of invisible particles. Physicists estimate that billions of dark matter particles are passing through your body every single second. They stream through your walls, through the mountains, and through the very core of the Earth, completely silently, without leaving a single trace. You are constantly being washed in a river of invisible cosmic dust. The realization that we are made of a rare, minority substance in the universe is a profoundly humbling experience. It displaces humanity from the center of the cosmic stage once again. The true substance of the universe is something utterly alien to our everyday experience. Yet, within this humbling realization lies a deep and beautiful comfort. Dark matter is not an enemy, nor is it a cold, indifferent force. It is the invisible architect of our existence. In the ancient, fiery moments after the Big Bang, the intense radiation would have prevented the formation of any dense structures. The universe would have expanded into a thin, featureless mist. But dark matter, immune to the explosive pressure of the light, was free to clump together under its own gravity. It formed a massive invisible web across the expanding void. This dark web acted as a cosmic scaffolding. Its gravity drew the normal matter in, pulling the hydrogen gas together until the pressure grew so intense that the first stars ignited. Dark matter was the invisible cradle that nurtured the birth of the very first galaxies. We owe our lives to a substance we cannot even see. There is a profound, poetic beauty in the idea that the foundation of our reality is completely invisible to our eyes. It reminds us that our human senses are limited, evolved to help us survive on a small rock orbiting a yellow sun, not to comprehend the absolute totality of the cosmos. Science is the process of building instruments that extend our senses. Yet even with our most advanced detectors buried deep underground in quiet, shielded mines, attempting to catch a single whisper of a dark matter particle, the ghost remains elusive. The true identity of dark matter remains one of the greatest unsolved mysteries in modern physics. Are these particles heavy remnants from the absolute dawn of time? Or are they incredibly light waves washing across the dimensions of space? Or perhaps the mystery points to something even more profound, gently suggesting that our fundamental understanding of gravity itself is incomplete and needs to be rewritten to accommodate the shadows. The silence of the scientific community in the face of this unknown is not a failure. It is the breathtaking space where true discovery happens. It is an invitation to remain curious, to keep asking questions, and to embrace the vastness of our own ignorance. When we look out at the universe and realize that we only understand 15% of the matter we are looking at, we are not diminished. We are elevated by the scale of the adventure that still lies before us. The mystery of dark matter invites us to accept that the cosmos does not exist to be easily understood by human minds. It exists in its own magnificent, infinite complexity, demanding that we approach it with deep respect and quiet humility. As you move through your day, allow the awareness of this invisible ocean to bring you a sense of peace. When you feel overwhelmed by the heavy burdens of your daily life, remember the invisible weight of the cosmos surrounding you. You are part of an incredibly intricate, beautifully balanced mechanism. The dark matter holding the galaxies together is the same force that brought the atoms of your body together in the ancient past. The invisible and the visible are locked in an eternal perfect embrace. You are not alone in the void. You are held together by the gentle, heavy hands of the universe itself. But dark matter is only half of the dark mystery that haunts our night sky. While the invisible gravity of dark matter is trying to pull the universe together, an even more terrifying and powerful phantom is tearing it apart. In our next journey, we will step into the most shocking discovery of the 20th century and explore the mysterious energy that is accelerating the expansion of space, driving the galaxies away from each other toward a cold, lonely end. We will peer into the mystery of dark energy. But for now, take a deep breath and rest comfortably in the invisible cradle of the cosmos. Let the unseen forces of the universe hold you safe as we continue to drift through the beautiful, infinite dark. Have you ever thrown a stone high into the air and watched it rise against the pull of the earth? For a brief, suspended moment, it climbs toward the clouds, but you know with absolute certainty that it must slow down, stop, and eventually fall back to the ground. This is the intuitive law of gravity, the gentle, invisible tether that binds our world together. For most of the 20th century, the greatest scientific minds on our planet looked out at the vast, expanding cosmos and assumed that the universe must follow this exact same rule. They knew the universe was expanding, born from the fiery singularity of the Big Bang, but they believed that the collective gravitational pull of all the billions of galaxies, all the heavy stars, and all the invisible dark matter would act like a cosmic brake. They thought the expansion must be slowing down, but the universe is a master of defying our expectations. When astronomers finally built instruments precise enough to measure the ancient light of dying stars, they discovered a truth so shocking, so terrifyingly beautiful, that it completely shattered our understanding of the cosmos. The universe is not slowing down. It is speeding up. It is being ripped apart by a mysterious, silent force that we cannot see, taste, or comprehend. We have entered the era of dark energy, the phantom force that is pushing the quiet night sky apart. Before we sail further into this expanding ocean of the unknown, allow me to warmly welcome you. I am Dmitri Isledovatil, your gentle companion on this quiet journey through the profound mysteries of the cosmos. As we drift through these ancient questions, I have noticed that 76% of the gentle souls who watch our videos and share in this quiet exploration have not yet subscribed to the channel. If the infinite vastness of space brings you a sense of inner peace, please take a moment to subscribe. It helps us immensely, allowing our small community to continue weaving these stories of the universe together. Now let us return to the dark, expanding void and the mystery that is quietly reshaping our reality. To understand the magnitude of this discovery, we must travel back to the year 1998. Two independent teams of brilliant astronomers were staring deep into the cosmic past, searching for a specific type of exploding star known as a Type 1, a supernova. These massive stellar explosions are incredibly consistent, burning with a known absolute brightness. By measuring how faint these ancient supernovas appeared from Earth, the scientists could precisely calculate how far away they were, and more importantly, how fast the fabric of space had been stretching since the moment they exploded. They expected to find the elegant signature of a slowing universe, a cosmos exhausted by its long expansion, gently yielding to the collective gravitational pull of its own mass. Instead, the data revealed a completely unexpected, almost impossible reality. The distant supernovas were much fainter than they should have been. The universe was not slowing down at all. The expansion was accelerating. The distant galaxies were rushing away from us faster and faster, driven by a phantom pressure that seemed to emerge from the very emptiness of space itself. The scientific community was initially stunned into a profound silence. This discovery was so deeply unexpected that the researchers themselves spent months looking for errors in their own calculations, hoping to find a simple mistake. But as more data poured in from other observatories, the terrifying truth held firm. Something was actively pushing the universe apart, counteracting the gentle, uniting force of gravity. Scientists named this mysterious, invisible presence dark energy, but it is vital to understand that the name dark energy is simply a placeholder for our own profound ignorance. It is a label we have applied to a vast silent mystery that we do not yet comprehend. It does not behave like the energy we are familiar with. It does not emit heat, it does not glow, and it does not form matter. It acts as a kind of anti-gravity, a repulsive force that seems to be a fundamental property of empty space itself. As the universe expands and creates more empty space, the total amount of dark energy grows, pushing the cosmos apart with ever-increasing ferocity. When astronomers calculate the cosmic budget, the total amount of everything that exists in the universe, the results are deeply humbling. The glowing stars, the swirling gas clouds, the planets, and the heavy atoms that make up your body, the mountains and the oceans, account for less than 5% of the total universe. The invisible ghost we call dark matter, the scaffolding that holds the galaxies together, makes up about 27%. But the vast, overwhelming majority of reality, roughly 68% of all the energy and mass in the entire cosmos, is made of this mysterious, repulsive dark energy. The universe is not a collection of stars floating in an empty void. It is a terrifyingly vast ocean of repulsive dark energy, dotted with tiny, insignificant islands of matter. We are the exception in a cosmos dominated by a force actively trying to tear the fabric of reality apart. The silence of the night sky masks a violent, accelerating expansion that is completely invisible to our human eyes, but absolutely devastating on a cosmic scale. What does this accelerating expansion mean for the future of our gentle, ancient universe? It paints a picture of a profound, unimaginable isolation. Right now, when we point our most powerful telescopes into the deep dark, we can see billions of galaxies stretching out toward the edge of the observable cosmos. We can see the glowing embers of the Big Bang and watch the majestic dance of galaxy clusters. But the accelerating expansion driven by dark energy is changing the shape of the sky. As space expands faster and faster, distant objects are receding from us at ever-increasing speeds. While the speed of light is the absolute speed limit for any physical object traveling through space, there is no speed limit for how fast space itself can stretch and expand. Eventually, the distant galaxies will be carried away from us by the swelling void faster than their ancient light can travel toward our quiet planet. When that happens, they will simply vanish. They will slip behind an invisible boundary called the cosmic horizon, forever beyond our reach, unreachable and unknowable. If the acceleration continues, the night sky will slowly, inevitably empty itself. Billions of years from now, the majestic tapestry of distant galaxy clusters will fade from view, their light no longer able to cross the aggressively expanding void. From the perspective of our distant descendants, if any conscious mind still exists to gaze upward, the observable universe will shrink and shrink. Our local group of galaxies, bound tightly together by their own local gravity, will remain united, eventually merging into a single, enormous, elliptical galaxy, against a backdrop of absolute, unbroken blackness. The rest of the cosmos will have slipped beyond the horizon. To those future observers, the universe will appear static, dark, and profoundly lonely. They will have no way of knowing about the Big Bang, no way of seeing the billions of other galaxies, and no evidence that the universe is expanding. The knowledge of the cosmos that we currently possess will be lost, erased by the relentless, quiet push of dark energy. The universe will become a sealed, solitary island in an infinite, unknowable ocean. It is natural to feel a deep sense of melancholy when confronted with this cold, dark future. The idea that the universe is destined for eternal isolation, that the connections between the galaxies will be severed by the silent void, feels like a tragic end to a magnificent story. But I invite you to pause, breathe deeply, and reframe this vast cosmic truth. The reality of dark energy does not diminish the beauty of our existence. It amplifies it to an extraordinary degree. We are living in a profoundly privileged, fleeting moment of cosmic history. We exist during the delicate, beautiful era of stars, a time when the universe is old enough to have produced the complex chemistry required for life, but young enough that the distant galaxies are still visible, still communicating with us through the ancient language of light. The universe has not yet pulled the curtain closed. We are the lucky generation of the cosmos, the consciousness that has woken up just in time to witness the full, breathtaking grandeur of reality before it slips away into the expanding dark. This realization should bring a deep, lasting peace to your quiet moments. When you look up at the vastness of the cosmos, do not fear the expanding void or the dark energy that drives it. Instead, feel a profound gratitude that you have the eyes to see it, the mind to understand it, and the heart to feel its immense beauty. The universe is a fleeting, magnificent performance, and you have been given a front-row seat to the most spectacular show in existence. The silent, invisible force pushing the universe apart is simply a reminder that everything in nature is temporary, including the night sky itself. But within that temporary existence lies a profound perfection. The fact that the universe can organize itself into conscious minds capable of deciphering the mystery of its own acceleration is a miracle that defies comprehension. We are the cosmos discovering its own fate, looking into the terrifying abyss and choosing to find wonder instead of fear. Let the mystery of dark energy be a gentle companion on your journey. It is a force that is shaping the ultimate destiny of everything that exists, yet it operates in complete silence, far beyond our mortal reach. It reminds us that there are forces in this universe vastly larger than our human concerns, ancient laws that govern the stretching of the infinite void. As we prepare to face the very end of time itself in our final exploration, we will look at the ultimate fate of the stars and the quiet, fading death of the last black holes. We will journey to the absolute edge of cosmic history. But for now, wrap yourself in the comforting embrace of the present moment. The universe is vast, the mysteries are infinite, and you are a beautiful, essential part of this expanding, miraculous reality. Let the quiet push of the cosmos gently carry you into a deep, meditative peace. Have you ever watched a single, beautiful candle burn down to its very end, witnessing the final, fragile flicker of its flame before it surrenders to the dark? There is a quiet, profound sadness in watching something beautiful end, but there is also a deep, essential truth in that final wisp of smoke. Everything that begins must eventually find its conclusion. We live our lives surrounded by the illusion of permanence. We look up at the mountains, believing they will stand forever, and we gaze at the ancient, burning stars, trusting that their light is an eternal fixture of the night sky. But the grandest, most terrifyingly beautiful revelation of modern cosmology is that the universe itself is mortal. The magnificent hologram that projects our reality, the vast, expanding ocean of space, and the deep, silent web of dark matter and dark energy are all moving toward a final, absolute silence. To truly understand our place in the cosmos, we must journey to the very edge of time, to the moment when the last lights go out and the grand illusion finally dissolves. It is a journey that will test our courage, but ultimately it will reveal the infinite, precious value of the present moment. Before we take this final step into the ultimate quiet of the cosmos, I want to gently welcome you. I am Dmitri Isledovatl, your companion on this long, peaceful journey through the mysteries of existence. I have quietly noticed that 76% of the kind souls who watch these videos have not yet subscribed to the channel. If you have found comfort in the vastness of the universe, and if these meditations bring you peace, please gently tap the subscribe button. It helps us continue to explore the infinite wonders of the dark sky together. Now, let us look to the far future and witness the fading of the light. As we travel billions and then trillions of years into the future, the cosmos begins to change. The violent, beautiful era of star formation, the epoch we are incredibly privileged to live in right now, will eventually slow down and cease completely. The massive blue stars will be the first to vanish, dying in spectacular supernova explosions that leave behind dark remnants. Yellow stars like our sun will swell into red giants, shed their outer layers in ghostly nebulas, and contract into dense white dwarfs. The tiny red dwarfs that burn their hydrogen fuel so slowly they can survive for trillions of years will be the last remaining beacons of light. But even they are not eternal. Eventually, perhaps 100 trillion years from now, the very last red dwarf will exhaust its final drops of fuel and fade into absolute blackness. The era of starlight, the beautiful, luminous phase of the cosmos that gave birth to life and consciousness, will come to an absolute, irrevocable end. The universe will become a graveyard of stellar corpses, populated by cold white dwarfs, neutron stars, and massive black holes drifting through a freezing void. The night sky will be completely, profoundly black, stripped of all its ancient glowing beauty. The silence of the universe will become absolute. But the story of the universe does not end with the death of the stars. As the eons roll by, measured in years with so many zeros that the human mind fails to grasp their magnitude, the remnants of the stars will begin to decay. Theoretical physics suggests that protons, the fundamental building blocks of all normal matter, might not be truly stable. Over unimaginable spans of time, they may dissolve into pure radiation. The solid structures of the universe will melt away into the dark. And what of the black holes, the massive gravitational monsters that swallowed the light of millions of stars? As Stephen Hawking proved, even black holes are not eternal. They slowly leak energy through the quiet mechanism of Hawking radiation. A supermassive black hole might take a googol years, a 1 followed by 100 zeros, to evaporate into the void. In the fullness of infinite time, even the largest black holes will radiate away their last bit of mass, disappearing from the cosmos in a final, silent burst of energy. When the last black hole evaporates, the universe will be nothing more than a vast, incredibly dilute sea of photons and fundamental particles, stretching infinitely in every direction, approaching absolute zero. This is the heat death of the universe, the state of maximum entropy, where all the energy is evenly distributed and no further work, no further change, and no further life is possible. The grand, magnificent hologram will have completely faded to black. What does this mean for the holographic principle, the terrifying and beautiful theory that has guided our entire journey. If the universe is a projection of quantum information stored on a distant two-dimensional boundary, the heat death represents the ultimate unspooling of that information. As the universe expands relentlessly, driven by dark energy, the information on the boundary becomes infinitely diluted. The quantum entanglement that weaves the fabric of space and time slowly unravels. The majestic three-dimensional illusion, the projection of galaxies and conscious minds, gradually loses its resolution. The pixels of reality drift apart until the image completely disappears. The grand cosmic hard drive does not crash. It simply powers down into a state of eternal, perfect equilibrium. The silence of the void is no longer a canvas waiting to be painted upon. It is a finished masterpiece that has been slowly, gently erased by the passage of ultimate time. It is a terrifying vision, a cold and lonely end to a story that began with such unimaginable heat and vibrant light. The idea that all our struggles and deep, quiet moments of love will eventually be swallowed by an eternal darkness can feel like a crushing weight upon the soul, challenging our desire for permanence. But I invite you, as a fellow traveler in this vast, ancient cosmos, to look at this ending through a different, more gentle lens. The fact that the great hologram is temporary does not erase the meaning of our existence. It is precisely what gives our existence its infinite value. A flower is beautiful exactly because it blooms for only a few fleeting days. If it were made of cold, eternal stone, we would not marvel at its delicate petals or breathe in its sweet, temporary fragrance. We are the fragile, beautiful flowers of the cosmos. We are living in the golden window of cosmic time, when the universe is warm enough and complex enough to support the miracle of consciousness. In a universe destined for trillions of years of cold silence, the fact that matter wakes up and asks questions about its own origin is a triumph of staggering proportions. We are the universe experiencing its own magnificent, fleeting spring. When you look at the stars, you are watching a breathtaking cosmic play happening right now. And you're both the audience and the lead actor. The atoms in your body were forged in the hearts of those ancient dying stars. And your conscious mind is the lens through which the universe is able to witness its own beauty before the lights go out. We must not fear the ending of the illusion, the heat. Death of the cosmos is not a tragedy. It is the gentle, quiet rest at the end of a long, magnificent life. The universe has labored for billions of years, expanding and evolving, to produce a mind capable of feeling wonder. And in you, the universe has succeeded beyond all measure. You are the ultimate realization of the holographic code, the beautiful, complex rendering of ancient quantum data. So, as we conclude this meditation on the nature of reality, let go of the anxiety of the infinite. Let go of the need for eternal permanence. Embrace the gentle, quiet reality of the present moment, for it is the only true reality we will ever know. The mysteries of quantum mechanics, dark matter, dark energy, and the holographic nature of space and time are all invitations to fall deeply in love with the universe, exactly as it is right now. It has been the honor of my existence to guide you through these quiet, ancient questions. The journey of learning is an infinite path, and though this specific exploration comes to a close, the night sky will always be there, waiting for your curious gaze. Thank you for walking this peaceful path with me. Until we meet again in the quiet expanse of the cosmos, keep your eyes open, keep your heart full of wonder, and remember that you are an essential, beautiful, and irreplaceable piece of the grand cosmic mystery.